Welcome back again to another episode of AWS SimuLearn Solutions Architect Path. Let's jump right into it. Let's try scripted mode first. Done. Let's do it again using open dialog mode. Done! We have a high client satisfaction score. Nice! Solution request. Improve the operational efficiency, availability, and performance efficiency of databases by using multiple availability zones and a read replica. Step 1. This solution uses Amazon Relational Database Service, Amazon RDS, which is fully managed and removes the need for manual database infrastructure provisioning and maintenance. Step 2. Amazon RDS automates backups, database snapshots, and host replacement to reduce the administrative burden. Step 3. To achieve high availability, deploy your database across multiple availability zones, AZs. In a multi-AZ deployment, Amazon RDS automatically creates a primary DB database instance and synchronously replicates the data to an instance in a different AZ. Step 4. When it detects a failure, Amazon RDS automatically fails over to a standby instance in a different AZ without manual intervention. Step 5. Because the name record for your DB instance remains the same, your application can resume database operation without the need for manual administrative intervention. Step 6. For read-heavy database workloads, you can create one or more read-only replicas of a DB instance. This way, you can serve high-volume application read traffic from multiple copies of your data, increasing aggregate read throughput. Alright, let's now go to practice section. Concept. In this practice lab, you will launch an Amazon RDS instance. Configure a multi-AZ deployment. Configure Amazon RDS backups. Let's check our architecture and familiarize ourselves. We can see here in our diagram that we have a primary database, a replica instance, and a failover instance. Let's discuss the two important features of AWS RDS. Read replicas and multi-AZ deployments. Understanding the difference between these two can help you design more efficient and resilient database architectures. Let's start with read replicas. Imagine you have a primary database instance that's handling both read and write operations. As your application grows, you notice that read operations are putting a lot of load on the primary instance, slowing down performance. This is where read replicas come in. A read replica is essentially a copy of your primary database instance that you can use to offload read traffic. The primary instance asynchronously replicates data to the read replica. This means there's a slight delay between when data is written to the primary instance and when it appears on the read replica. Read replicas are great for improving read scalability. You can create up to 5 read replicas for MySQL, MariaDB, and PostgreSQL, 2 for Oracle, 4 for SQL Server, and 15 for Amazon Aurora. These replicas can be in the same region or even in different regions, which also helps with disaster recovery and geo-distribution. Now, let's talk about multi-AZ deployments. While read replicas help with read scalability, multi-AZ is all about high availability and fault tolerance. In a multi-AZ deployment, you have a primary instance and a standby instance in a different availability zone. AWS RDS uses synchronous replication to keep the standby instance in sync with the primary instance. The key difference here is that multi-AZ deployments are designed for automatic failover. If the primary instance fails for any reason, like hardware failure or a network issue, AWS RDS automatically switches to the standby instance. This minimizes downtime and ensures that your application continues to run smoothly. To summarize, read replicas are used for scaling read operations and can be placed in different regions, while multi-AZ deployments are used for high availability and automatic failover within the same region. Both features enhance the performance and reliability of your databases, but they serve different purposes. Alright, let's start to launch an Amazon RDS instance. Here in our example, we are going to turn off performance insights. But in the real world, this is very useful and often used for database performance tuning. Let's wait until our database is completely created. Done! The creation of our database is now complete and we can see its status as available. Let's proceed. Congratulations! We've completed the practice session. Let's now go to the DIY section to complete the solution. DIY goals. Create a read replica of your primary database using a db.t3.extra large instance. Here, we will select Do Not Create a Standby Instance because we are creating our read replica, not our multi-AZ or failover database. Alright, our red replica is now creating. But we can try to validate our solution and see if we'll pass. Congratulations! We successfully created our RDS instance with replica instance and failover instance configuration. Sweet! Let's check one last time the diagram. We have created this multi-AZ deployment by selecting this in the option while creating our primary instance. Then we have created our read replica in the DIY. Well done! If you like this kind of content, make sure to hit that subscribe button and ring that notification bell. Until next time, folks, bye!